Hello dear students. In this session we are going to discuss about a very important topic in engineering mathematics called numerical integration. So what is numerical integration? What is the importance of this numerical integration in real world problem as well as in mathematics? We are going to learn step by step. See, first thing, why the numerical integration is important. See, usually what happens, most of the problems comes in engineering as well as in other fields of engineering are related to engineering. Many of the time, some of the integrals may not be suitable to solve with normal traditional integral methods. So, in that case, we are supposed to use the numerical techniques which gives an approximate answers. For example, see, you take one real world problem like we do not know the distance between from Earth to Moon. But even though, based on the approximation techniques, we can easily calculate the distance between Earth and Moon, so that based on the approximate data, we are sending satellites and other things to the Moon. Okay, so like that, we may come across many real world problems which requires numerical techniques. So when it comes to numerical integration, this is the process of obtaining approximately the value of the definite integral. We know what is the difference between definite integral and the indefinite integral. So any integral with limits is called definite integral, and any integral without limits it is called indefinite integral. See, you see, this is the standard representation of definite integral I equal to integral a to b y dx. Here this y is called function, the given function. So what exactly numerical integration do? Numerical integration will evaluate this definite integral without actually integrating the function, but only using the values of the given function y at some particular points of x equally spaced over a comma b. This a comma b represents the interval of the given function, and this interval will be separated, or it should be divided into equal parts. That is the reason it is called equally spaced intervals, and that is nothing but x intervals or x values. Now you just see here, if we consider a simple function f of x defined in the interval a comma b at the points of x like x0, x1, x2, x3 dot 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 xn, and the corresponding functional values are f of x0 equal to y0, f of x1 equal to y1, f of x2 equal to y2, f of x3 equal to y3, etc., f of xn equal to yn respectively. For every value of x, if we define the given function y, these are the corresponding functional values. And that functional values are also denoted by f of x0, f of x1 as well as y0, y1, y2, y3, etc. Based on these values, here I am going to discuss four important numerical integration formulae or numerical integration techniques. The first one is trapezoidal rule. So what it says, trapezoidal rule is a very simple and easiest numerical technique which is used to solve the integrals in the form a to b f of x dx, which gives the formula h by 2 y0 plus yn plus 2 into y1 plus y2 plus y3, etc. Here, how to remember this formula? H is nothing but what? Length of the interval x. X we have like x0, x1, x2, x3, no? So x0 to x1 we have length of the interval, x1 to x2 we have length of the interval, x2 to x3 we have length of the interval. That length is denoted by h. So y0 plus yn, y0 is the starting value of the y and yn will be the last value of the y, plus 2 into the remaining values of y, y1, y2, y3, y4, y5, y6, etc. So this is one simple rule which is used to evaluate the integrals without actually integrating the function. Next we have Simpsons 1/3 rule. So what it says, integral a to b f of x dx, that is equal to h by 3 y0 plus yn plus 4 into y1 plus y3 plus y5 etc. plus 2 into y2 plus y4 plus y6 etc. So how to remember the Simpsons one-third rule? So it is usually denoted by h by 3. Again y naught plus yn. Y naught is the starting value of y. Yn is the end value of y. 4 into odd multiples of y, odd values of y like y1, y3, y5, y7 we have to write, plus 2 into even values of y, y2, y4, y6, y8 etc. This is how we have to remember. Simpsons one-third rule means 4 into odd values of y, 2 into even values of y. So the first step is y naught plus yn. The next important rule is Simpsons 3 by 8 rule. So that is integral a to b f of x dx, that is equal to 3h by 8 y naught plus yn plus 3 into y1 plus y2 plus y4 plus y5 etc. 2 into y3 plus y6 plus y9 etc. Now you see this proper sequence: 3h by 8 y naught plus yn, 3 into all the values of y except y3, y6, y9, means multiples of y will come here. Other than the multiples of 3, we are writing values here: 3 into y1, y2, y4, y5, y7, y8 like that, and 2 into multiples of 3 like y3, y6, y9 etc. This is how you have to remember 3h by 8. And here Weddell's rule, it is very simple and interesting rule. Here this Weddell's rule, I have not written the general form. I have restricted this Weddell's rule for this particular session for 6 values, means 6 intervals. So what it says: 3h by 10 y naught plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. Okay, so here h will be the length of the interval, so it is denoted by b minus a by n. And how to remember this? You just remember the sequence: 1 5 1 5 1 6 1 5 1. 1 into y naught plus 5 rule. How to remember? 1 into y naught, 5 into y1, 1 into y2, 6 into y3, 1 into y4, 5 into y5, 1 into y6. This is how you have to remember the Weddell's rule, by remembering the sequence: 1 5 1 6 1 5 1. And everywhere we use the h, length of the interval. Sometimes it is given in the problem itself. If they are not given, you have to find the length of the interval, h equal to b minus a by n. Here n indicates what? Number of strips. You remember this: strips is different, number of observations are different. Say strips means, let me take one example here: x1, x2, x3, x4, x5. So x1 to x2, x2 to x3, x3 to x4, x4 to x5. This is called strip. How many strips are here? 1, 2, 3, 4 strips are there. And for 4 strips, how many values are there? 1, 2, 3, 4, 5. 5 values are there. Therefore, for n number of strips, we will have n plus 1 observations. Okay, so you remember that. And usually sometimes if y values are there given, they may tell for m number of strips you may have n number of y values also. Okay, so this is how to remember. And here very important note everybody should understand and remember. This is very important: when to use trapezoidal rule, when to use Simpsons one-third rule, and when to use Simpsons 3 by 8 rule and Weddell's rule. If they have not mentioned in the problem statement which method is suitable, you have to decide. If they mentioned like using trapezoidal or using Simpsons, you can go ahead. But sometimes simply they may give an integral problem, use appropriate numerical integral technique and solve this. Then you have to know these things. What is that? Trapezoidal rule. If we want to apply trapezoidal rule for any problem, to evaluate any integral, so everywhere you see we are taking n values, everywhere here n values. So to operate trapezoidal rule, n should be multiple of any value except 0. Means you see here I have taken n equal to what? 1, 2, 3, 4, 5 means n equal to 4. 4 strips should be there. So for 4 strips, n plus 1 values must be there. So to operate trapezoidal rule, the number of strips may be anything. There is no restriction. If we have 50 also, 60 also, 2 also, 4 also, we can operate. It depends on the problem requirement. But when it comes to Simpsons 1/3 rule, we have a proper rule that n should be multiple of 2. If we want to operate Simpsons 1/3 rule for any integral, so we have to remember that n should be multiple of 2. 2, 4, 6, 8, 10 like that. Means at least 2 intervals are required to operate Simpsons 1/3 rule. And when it comes to Simpsons 3/8 rule, n should be multiple of 3. If we want to operate Simpsons 3/8 rule for any problem, we have to remember that n should be 3, 6, 9, etc. Means at least 3 intervals or 4 values are important or must required to operate Simpsons 3/8 rule. And to operate Weddell's rule, n should be multiple of 6. At least 6 interval values must be there to operate Weddell's rule. As I said, here I am not using general Weddell's rule. I am restricting myself n equal to 6. Means minimum requirement for the Weddell's rule I am taking here. And n equal to 6 means 6 is multiple of 1 also, multiple of 2 also, multiple of 3 also, multiple of 6 also. Therefore, for n equal to 6, all the 4 methods are suitable. Trapezoidal rule, Simpsons 1/3, Simpsons 3/8 and Weddell's rule, all are suitable for n equal to 6. But the reverse part is not same. Okay, for every n value, we can't operate Weddell's rule. To operate Weddell's rule, at least 6 interval values we must have. Okay, this is the basic information everybody should know before going to the problem sections. So in the next session, we'll discuss few problems based on all the 4 methods. Okay, thank you.